Okay, so that was 50% duty cycle. That was before, I remember last video I changed 10. I didn't basically upload the new code. So let's upload the new code. Now it's going to be 10. Let's look at the waveform real quick. Now if you look at that, that's 10%. And that's pretty nice. And you know, this is all being done without the main loop. It's actually being done as an interrupt, right? And really the idea is once you're done counting X right here on the bottom of the wave, you count, then you just switch the new value for the compare to 10 minus X, and then you basically toggle the port B pin 1. So this code is pretty nice. It works. And real quick, we're going to change that to a 70. So if it's 70, we can go here and we can do 70 right here. Okay, so now look, it's 70% on, 30% off, roughly, I guess. Now let's actually, this is all hooked up with the actual the motor. I believe that's a motor. So what I have is that yellow wire you see right here. This yellow wire is actually the ground. It's connecting the ground on this side. So this side is actually the bottom side is the ground for the 9-volt battery, and on the top side, this is a 3-volt source. 3-volt source that's powering up the optoisolator. So this part of the circuit right here you see, that's the optoisolator part. This part of the circuit is the motor part. So again, without getting into too much, this is a 3-volt power source, and you look at that, that's the ground on top. That's exactly where the yellow wire is connecting to the bottom. So everything, you know, for, I guess, just for safety, no ground loop currents or something like that. Anyways, so looking at this right here, this is a 70%, right? So what we're gonna do is we're gonna see how fast this is spinning, and what we can do is if we set it to 10%, so now the waveform is gonna go back to 10% duty cycle, and for the 9-volt source, it's basically gonna be this thing right here. Okay, so that's a 9-volt source, and you can hear right here it's spinning. And you can actually hear it. Okay? It's a small hearing sound. You can hear it. But what we're going to do is we're going to spin it faster. Now, it spins, and it basically is very, and you know, we can actually see, if I were to put a hole in there, it would spin slow, and it's pretty faint. So what we can do right now is we can actually speed up the count, and so we're going to change the pulse to let's go 90. I think 90. So as opposed to 10, now you have 90, and the waveform should change. And here we go. So the waveform change. Okay, and look at that. Look at how loud that is. That's much louder. Okay, and and we can just, for comparison, if we set it back down to like 20. Okay, now it's gonna start uploading, and pretty soon. Okay, now the code uploads, and now it's much it's more silent, right? You can kind of hear that. And then you can look at the 20% duty cycle and the 20% right here. Okay, so this shows that the code works for the pulse width modulation, and the thing is spinning the way it's supposed to be. We know that this is just 0 RM right now, but because of the code, the way the code is written right now. But for this portion of the code, for the motor, it's working. The timer 1 is working. We saw the PCB is working, and the optoisolator code is working. Okay, so the main thing is now the optoisolator that itself, as I sent an email to Sylvia, that basically when we power up the optoisolator, and you know, just for confirmation, I did solder it because to see, like, for better connection. And it's still, if you look at it, it requires a very high voltage actually to get a decent voltage difference. So if we have we put something in the slit and we take it out, it's only going to change a couple of, like maybe 3 centivolts or like 30 or 40. I mean, it might be a little bit, but I think it's not enough for the butterfly board pin 4 to recognize that that went from high to low. So the idea is, and this is what I proposed in the email, if I basically jack up the voltage, that's basically this guy right here, these two wires right here, because they're powering up the optoisolator, that jack it up to 20 some volts or something, realistically, and then the idea is it works better. The difference when you put something in and take something out, the difference is more. And then basically put a diode on pin 4, because pin 4 is reading in there somewhere in this right here. Actually, this black wire right here, you see right here, that is reading from, I believe I want to say it's pin 3. So I think it's pin 3. But this right here, that's where it's reading from. So if you put a diode there to stop any current from going into the board, we might be able to, like, I mean, it might be, not exactly sure what that would do, because it still would show a 20 some volt potential difference, or 20 some volts on the pin 4. So that was a proposed thing, but the idea is this optoisolator is not really fit for the job. Again, the code works. I've shown that through the videos, and I've shown that the individual parts work. I showed that also that this, I haven't shown that, I can show this, that this does work, but it's not working as much. Okay, so like it's not working as effectively because it needs a higher voltage difference. Anyways, so this is the last part of this is pretty much everything's working, and this hopefully shows that the code works and the methodology is correct. It's really 3 interrupts. One's for timing, counting to 1 second. That's using the timer 1. Counts for 1 second. At that moment, it basically calculates the rates per minute, and it also clears revolutions done. That's being counted by the other interrupt, which is using timer, which isn't really using a timer. It's just every single time the optoisolator goes off, pin B should change. Either way, pin B does change when we individually do it, switch it from high to low, and that basically counts the revolutions done. And then the third interrupt is basically the third interrupt was for basically timer 0, and that's the output compare, and that's basically for the pulse width modulation. So effectively the code does work. So